Hello, can you hear me? Hello, can you hear me?
Yes, I can hear you.
Yes.
All right, how are you guys doing?
Good. How are you?
Fine, thank you. So today like I explained last time, today we begin uh, a new topic, which is the measures of position. Measures of position, and that would be our focus this week, and then probably we'll finish this by Tuesday. Now, uh, measures of position, we use them to locate the relative position of data value in a given data set. Now, for example, if your credit score is located in, say, 80th percentile, that means your credit score is better than 80% of better than the credit score of 80% of Americans. That's what it means. So and so on and so forth. So those measures tell us the relative position of a data value in a data set. We call them measures of position. And they include these measures here. They include the standard score, or what we call the Z-score, percentile, deciles, and quartiles. Today we focus on standard score and percentile. The standard score simply means the number of standard deviation a given value X falls from the mean. And the formula for finding it is on the screen here. Z equals value minus mean divided by the standard deviation. Or you can just use symbol to write in this form. X minus mean divided by standard deviation, where Z represents the standard score. X, the data value. Delta symbol represents the standard deviation, and this is the mean. Now, remember I mentioned when we are in the class at the campus that we use population this to represent population mean, mu, and sample mean we use X bar, and our variance we use this symbol, and for population variance and for sample variance we use this S squared. Population standard deviation we use 1 delta, and the sample standard deviation we use S. Now let us look at the other measures. Percentile. Percentile divide a data set into 100 equal parts. Okay? Percentile divide a data set into 100 equal parts. Then decile divide the data set into 10. Quartiles divide them into 4 groups. But the one we're interested in is the first quartile, which is Q1, second quartile, which is Q2, and third quartile, which is Q3. We'll be discussing quartile on Tuesday. So let's focus on percentile today. So which means that we have other measure we call mid quartile, which is a rough estimate of the second quartile. This is the formula for that. And outliers. I explained that in the classroom. Any data value that stand out from the group. Now, the exploratory data analysis, we'll be doing that to examine data values to find out which information we can get from them. Information like the spread and the center. Now, let's look at how to compute the first measure, which is the Z-score or the standard score. How do you calculate it? Look at this example here. It says here that a student scores 60 on a math test that has a mean of 54 and a standard deviation of 3. Now she scores 80 on a history test with a mean of 75 and a standard deviation of 2. On which test did she perform better? So let's see. To do that, we have to calculate the standard score. Solution. And you remember the formula for that standard score. I'm going to get it from there and place it here. This is right here, this formula right here. X minus mean divided by standard deviation. So we're using this formula for this equation. For this equation. In this case, they said mass test. For mass test and for history test. Okay. For mass test, the mean, okay, equals, according to the equation, make it 18. The mean equals mean of 54. And for history test, the mean is, for history test, the mean of 75. Then for the standard deviation for the mass test is 3. The standard deviation is 3. Okay. And the standard deviation for the history test, okay, is say with a for the history test with a standard deviation of 2. Now, what did this student score? The score she had in the mass test is 60. So our X equal 60. Okay. And for the history test, her score is 80. So we're going to calculate the z-score for all this, for the math and history. So remember the formula is z equals x minus mean by standard deviation. You must have that in the back of your mind. So that means for the math test, for maths, oh, excuse me, you have z equals, you say x minus mean divided by standard deviation. We have our x is 60 minus the mean of 54 divided by the standard deviation of 3. Now I'm going to write this down so I can get it for next lecture. Z equals 60 minus 54 by 3. Okay. So we're going to use a calculator to get that. So we got 60 minus 54 divided by 3. 2. Got 2. 2. Which means that, how do you interpret this? Interpretation. The student score in this is for maths, okay? This student's score in maths is 2 standard deviations above the mean. So his score is above average, and the score in maths is above average, and it's 2 standard deviation above the mean. Now let us check the score in history. For history, we have this. Okay. Yeah, make it 80. So what he had in 80 history, z becomes equal. For history, he said s is 80. Okay. So I'm going to put 80 here. And what's the mean of 75 divided by standard deviation of 2. So I'm going to put this on paper. Z
Good
equals,
afternoon, Dr. OG.
yes, ma'am.
I'm sorry, I was having some issues with the link. I didn't see the one that you usually resend. Could you let me know what we're going over in the moment, please?
It's the same one we're using. So what do you want? What do you want to know? We use
What
the
are we
same link.
starting with?
We use the same link every time we have remote. That's what I say in my
Okay,
announcement. No,
okay.
no new link. So what is your question again?
What are we going over?
We started with measures of position. So we are working on the z-score now, standard score.
Okay, thank you.
And this is the formula right here. Did you just join in?
Yes.
Okay, that's okay. We just started doing this. This is the formula we are using. And this is the question we are solving here.
Okay, thank you.
You're welcome. So now, 80 minus 75 divided by 2, we have 80 minus 75. Let me write it down. Divided by 2. Okay. You have 80 minus 75 divided by 2. 2.5. So answer we got is 2.5. 2.5. And the interpretation of this is okay. The student score in history. Score in history is 2.5 standard deviation. Above the mean. So the score is above average and it's 2.5 standard deviation above. The other one is also above average, but it's two standard deviation above the mean. So this one is because the question was asking us on which test did she perform better. Of course, she performed better on this one because it's higher. It has a higher standard deviation above the mean. Now note that if this is negative, this is the answer is negative. Now that means we will be using below the mean. Let me add something here. Let me say, suppose I ask them, suppose I add a question here. That she scored. Okay. So let me add this one. Suppose, yeah. Suppose the student scored 50 45 and then let me put it right here. Suppose uh the student she scored 45, or let's say it's scored 65 on a biology test, right? With a mean of 75 and a standard deviation of 2, for example. In that case, say the student mean is make this in bold, make it not bold really, make it 18. That means the mean equals 75 and standard deviation is 2. I'll say delta is 2 and the student score, which is x, is 65. In that case, the z-score, z will become equal x minus mean, x is 65 score minus mean of 75 divided by standard deviation of 2. Okay, let me try this one. All right, 65 minus 75 over 2. So you can go and get it from the calculator. Okay. Okay, I can just change this to 65. Give me negative 5. Negative 5. Okay. Negative 5. So how do we interpret this one? The interpretation. Okay. The student's score, the student's score is 5 standard deviations. Deviations below the mean. This one is below average. We say below the mean because of the negative result. So in this case, the score in biology is still because the question again says on which test did she do better. So let me add this one to that question so that yeah, add this to that so that we can okay. She also add it so that our she also scored okay. So that's number 1. So she also scored on which day did she perform better? Okay, let me make it number 18. Now, can see the difference. This one is 2 standard deviation above the mean. These first 2 are above average, but this one is highest above average. That's why he scored better. This one, even though the number is bigger, but it's a negative number, which means that it's below average. So he didn't do well on that test. Any question on this? Any query? Yeah, that's no question. Excellent. Now, we can now take a look at, when you at home, you can try this one as for your practice. Let me take you to uh, percentiles. Now, percentile divided a data set into 100 equal groups. So, to find the percentile, we use there are 2 ways we can two ways we can do that. Either you are looking for the percentile rank, or you are looking for a number that corresponds to a particular percentile. Let's try that with this example. Say a teacher gives a 20-point test to 10 students, and the scores are shown here. It says, find the percentile rank of the score of 12. Find the percentile rank of the score of 6. Find a value that corresponds to 25th percentile. That is to locate the 25th percentile. That's another way of asking it. Locate the 25th percentile from the list. Now, find the value that corresponds to the 60th percentile. Okay. Now, we can, for locating the percentile, we use this one. And for finding the percentile rank, as a matter of fact, percentile rank, as it says, find the percentile rank. So we're gonna use this one to find the percentile rank, and to locate the percentile, we use this one. So let's do an example. First thing you do is to put the numbers in the ascending order of magnitude. That means from smallest to largest. I did that here. Then I use this formula to find the percentile rank. How many numbers do we have there? Let me make it 18. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our number of values is 10. Okay. And we are asked to find the percentile rank find the percentile rank of the score of 12. So our X is 12. So percentile rank now becomes, you put this values in this formula here. Number of values below X plus 0.5. But this 0.5 is a part of the formula. It's a kind of correction for continuity, divided by total number of values times 100. So in this case, we have, I'm gonna write these numbers down so I can take you to where we can put it. And in the formula that will allow us to put the values inside this formula. Let me write the formula. The number of values below X plus 0.5 over total number of values, which is this case is 10 times 100. So in this case, our X is 12 and total number of values N is 10. So let's go and put them in the formula. Okay, we have I'm going to use this workbook. So you can say insert. Okay, percentile equal. So I'm gonna make this in 18, font of 18. Okay, we have, now look at this. Before we do that, it's a number of values below X. Our S is 12. So now how many values are below 12? This is 12 right here. How many are below 12? 1, 2, 3, 4, 5, 6 numbers are below 12 in value. So you're gonna put 6 right there. Okay. 6. Then say plus 0.5. Divided by how many numbers do we have there? Well, it's a test given to 10 students. So you have 10 numbers here, 10 scores here. Okay. So we're gonna put 10 right there. Okay. And times 100. So we have I'm gonna put 6.5. Sorry, 6 plus 0.5 over 10 times 100. So let's go and put this on the calculator. We have 6 plus 0.5 divided by 10 times 100. 65th percentile. So we're going to call it 65th percentile. 65th percentile. Yeah. So that's the answer we got for that. We're going to go and put them right there in our women workbook. See? So you can see number of values below X. These are X here. X is 12. Number of values below X, which is number below 12. 1, 2, 3, 4, 5, 6. You can see the 6 right here. Then plus 0.5 divided by total number of values. We have 10 students that took the test. That gives 65 percentile. What does this mean? It means that the score of 12 falls in the 65th percentile, which means that any student who have that score performed better than 65% of the students who took the test. Okay. Now, so part B, you can, say find the percentile rank of the score of 6. Here, you have how many of them have how many numbers. I'm gonna make this again. Make it 18 again. Okay. We have the numbers of 10 students to the test. And this time around, they're asking for the percentile rank of the score of 6. So our X is 6. So how many numbers are smaller than 6? Say 1, 2, 3. So we go there and put this here, right? 1, 2, 3. So you have 3 numbers below 6 plus 0.5 divided by 10. What are you gonna give us? Okay, let's see. Check the calculator. Make it 3 here. 35, which is 35th percentile. Give us 35, 35th percentile. So any student whose score is 3 perform better than 35% of all the students that took the test. Okay? Sorry, give us the here. Now, there's another way they ask the question. You might ask to locate the percentile. For example, here it says, find the value that corresponds to 25th percentile. That means it's asking you to locate the 25th percentile from the list. That will require a different formula, which is this one right here. Where n represents total number of values and p is the percentile of interest. So if this time around, I say find the value corresponding to 25th percentile. That is to locate the 25th percentile from the list. So in that case, what you're gonna do, excuse me, already we have it numbered. So our n is 10 numbers. And you're looking for the 25th percentile. That means P is 25. So you can plug this into this formula. N times P over 100. So that P25, I mean, it's 25th percentile equal. I'm going to make this thing to be 18. 20 is good. P25, that means the 25th percentile, okay, equals N times P. Our N is 10, our P is 25. So N times 10 times 25 over 100. Excuse me. So I have 10 times 25 over 100. That's 10 times 25 over 100, which is 2.5. 2.5. So whenever you have a decimal in this form, you run to the next whole number. Okay? So you have 2.5, which is 3. Go to the next whole number, which is 3. Now from there, this is the counter. You're gonna count 3 times. So you go here and count. 1, 2, 3. The third number. Okay, third number, something like 3 is the third number, which is the third number, okay? Third number. So third number will be 1, 2, 3, which is 5. How do you interpret this? Say the score of 5 corresponds to the 25th percentile. Now, any question to what I have done so far? Any question? Excellent, excellent. No question, good. Now, let's answer the last question in that section, which is say find the value that corresponds to the 60th percentile. In this case, n is 10, but p is 60. Okay. Let's pass D. N is 10 and p is 60. Make sure you're seeing this. 60. So in that case, percentile we're looking for now becomes we have the formula right here. It's called arranged. I use gonna use this to find it. So let's do that one. N is 10 to N P60 becomes P60. P60, I'm gonna make it unbold it. P60 becomes that's this is the percentile be 10 times 60 over actually not over 100, correct. That give us when I go and put the calculator 10 times 60 over 100. Let's change this to 60. Give me a 6 even, a 6 even. Now when it is an even number like this, what you're gonna do is to call that number 6, which is the sixth number plus the seventh number. If it's a decimal like this one, 2.5, you go right to the next number. But if it's an even number like this, no decimal, you go to that number plus the next number plus the seventh. Okay, divided by 2. Okay, so you have the sixth number. Don't forget to put it in the parentheses. The seventh number divided by 2. And the sixth number from the list is, see, we have 1, 2, 3, 4, 5, 7, 10 right here. Okay. 10 plus the seventh number, which is 1, 2, 3, 4, 5, 6, 7, 12. 10 plus 12 divided by 2. And that will give us the result. I equals 10 plus 12 is 22. Divided by 2 is 11. Can verify that. So the number that of the score of 11 corresponds to the 60th percentile. That's what it means. Any question on this? Okay. So since there's no question, I will say when we come to the next class, we begin with quartiles. But don't go yet. Let me get all your names. If I don't call your name, that means I have your name here already. Yeah. Destiny, is you here? Destiny, are you here? Yeah, she's not here. Okay, then. Kai Heston. Heston? Heston, you here? Not here. Kofi Hall. Hannibal Elliott. Christopher Leary. Kobe Lay. Lily Navia. Okay. Paris Anthony.
Here.
Okay. Jairo Richards.
I'm here.
Richard, Jairo, you here?
Yeah, I'm here.
Okay. Mia Russell. Justin Tisdale. Tedian Tukula. Benjamin Oliver. Devin Williams. Okay, if you didn't hear your name, that means I already have you checked in. So So, all right, guys, any question for me before we leave?
No,
No.
thank you.
All right. I see you guys on Tuesday then.
Have a nice day.
You too.
Did you mark me here?
If I didn't call your name, that means I've already marked you. What's your name?
Kendra
Last name is,
Pascasio.
yeah, I marked you already. That's why I didn't call
Okay,
you.
thank you.
Welcome. All right, guys. See you guys next week. Holland.
Here.
We just finished. I'll see you next week, okay?
Oh, okay. I'm like, because I had dropped out of the call and then I came back.
Oh, okay.
Okay. All right.
Miss Kaya Wise. Wise.
Here.
What can I do for you? You are still here? Everybody's gone?
No, I just wanted to make sure that I knew about the percentiles, but I think I just figured it out looking at it again.
Okay. All right.
But thank you.
Nominees on the show.
Welcome. I see you next week in class, okay?
Yes. Have a good one.
Hours.
Bye-bye.